Hello, my name is Jordan Richardson, and this is CSE 546, Introduction to Machine Learning, homework number 5. For this assignment, we used the k-means clustering algorithm on a set of real data. We had to optimize the parameters of k-means by analyzing it. That was k. And then we also had to analyze and compare the clustering results after that. With a variety of other tasks to help us accomplish this, such as the silhouette plot, the silhouette coefficients, and identifying samples at the core and at the boundary, and displaying those images, and then computing the adjusted rand index by comparing it to the ground truth in the data. This was the README. It just gives you a general understanding of the data. There's 10,000 images from 5 classes: plane, car, bird, horse, and ship. So that's what all of these images consist of. There's 128 features. This is the IDs they correspond to. This is how the image is stored. So that's how you need to represent it or shape it. So let's go over the code. So I did helper functions at the top just to stay more organized. So the first function is for computing the sum of squared errors, k-means. That is important because it helps us identify where the best parameter or value for k is. This then plots those values. This is plotting the silhouette value that we'll cover later on, but it takes the number of clusters that we'll select as the optimal value. Does the silhouette score for each sample, plots it, and then loops repeatedly over to get it plotted for every single image, because there's 10,000. And it selects a color for that cluster, and you'll see the image. It's actually pretty interesting graph. This one's for finding the core and boundary images or samples. It also uses the number of clusters depending on that. And then we store toList to collect the values, and this is what we need it to be a boundary sample. So it just goes over the clusters, gets the indices, gets the top 5 samples with the highest, and then it finds the boundary. Basically, we just take the first 2. This displays the images, so it gets the number of images, and then loops over, reshapes it, and displays it for whatever you're calling to it. This was one of the ways I was trying to verify if my estimated sum of squared errors, yes, was helping me to correctly estimate the best k. And then I was taking the third difference as well to further highlight that. So this just reads in the data. I flattened y for later on for computing the rand or the ARI. So we'll run it, and then I'll keep going through it. But I was checking the shapes just to verify everything was the way I needed it to be. And then we loop over all the k's in the cluster range, which is 5 to 16 for this assignment. And actually, I'm going to run that again. And then we'll pick the best k. This prints the differences down here, so you can look and go through and see if you might have an opinion. I initially chose 5 because when looking at the graph, The first really decrease is right here. So from there, that's the bend, and it continues the decrease, which as it goes on, it's just slowly slanting more. So you enter the optimal number of clusters. We'll go with 5 because that's what I initially chose. It calculates the average silhouette score, and then here is the graph from that. So the way this works is these are the 4 or 5 groups in the data set. This is the positive negative line. And so the bigger this is and the higher out it is and the thicker it is, the more coefficients are on this side. But you can see quite a few are in the negative, which would mean they're poorly clustered. It's just that they're not clustered very well to get organized. And then these are the core samples. So the horses, planes, cars, birds, and ships. These were the core samples. These are the border samples, or at the boundary, which you might be able to understand why these could be classified, possibly mixed up. And then it computes the adjusted rand index. Thanks. Hi, my name is Jordan Richardson, and this is Homework 5. This is my presentation for CSE 546, Introduction to Machine Learning. So for our agenda, we'll first have an introduction. I'll go over my initial thoughts of the assignment, and then we'll jump right into the k-means clustering algorithm. So for this project, we were to apply the k-means clustering algorithm to a real data set, and we wanted to analyze and optimize the parameters of the k-means clustering algorithm within k equal to 5 to 15 or 16. And we want to analyze and compare the clustering results. My initial thoughts was I found this assignment interesting. One, because of using real data, but also because we're using the k-means clustering algorithm, which I've actually had some experience with. Basically on the side after I took artificial intelligence and we learned a lot about different algorithms. I used this at one point. So the k-means clustering algorithm. So for development, this model is quick for me, so I was able to quickly get results going, eventually find an optimal k, and proceed through the rest. I am trying to be more organized with my code in general because I have gone full-time. So on the left you can see the functions I made for this assignment. Choosing k. Here's the graph I got when plotting the SSE for each k from 5 to 16, 0 indexed, so 15. But the values are below. But you can obviously tell there's no elbow point on this graph. So I tried to estimate by zooming in, and you can clearly see that the bend starts right away. There's just a slight distance there, or difference there. So I chose 5 in the end, and then I decided basically I'd verify with ARI. And then this was also reinforced later on by understanding when reading the README that there are 5 classes in the data. This is the silhouette graph I generated with k being 5. You can see from the graph the orange likely has the highest silhouette coefficients. None are negative. Green would be second, black would be third, blue would be fourth, and teal would probably be last. But some of those could be interchangeable or be close. Higher coefficients basically indicate better separation from other clusters. But those that are negative are basically probably poorly clustered or have a higher chance of being. Here you can see the 5 sample groups, and there's 5 samples that are at the core of each of the 5 clusters. The original groups were horse, plane, car, bird, ship, and that's what we got as well. But these are relatively easy to find. Let's look at this one down here. So these are on the boundary, so they could be considered poorly clustered or easily basically confused. And you can kind of see why if you look at the image that it might be easy to mistake these. And then for the adjusted rand index, I got 0.7701 as my final best result. And further research and just work on the project on how to acquire better results. I basically set it up to loop through all the possible k values that we were given by the teacher, and still acquired k equals 5 as the best value. K and 7 and 8 were probably the best results other than 5 if I decided not to, or that I could not. Thank you.